can't chat to it, can I don't know. All right. Let's see here. All right. Okie doke. Yeah. So I'm working on I'm working on type hoisting. So they don't have to be emitted at the same, or they don't have to be emitted in order. What's up, Jomi? How you doing, buddy? We are bootstrapping today. I technically already migrated everything to this migration file, and then I do this little hacky thing where I do like a C block. I do the C block, and then the parser reads this whole thing as one big token and then just dumps it in the code, the generated code. So I'm trying to get rid of all of these and be fully off of it. But I have these declare arrays that I do for some arrays, but I think I might just emit these every single time I generate a type, which will bloat the code a lot, but I'm not using Bison. I wrote everything. I have to write everything in C. I wrote the lexer, then the parser, and then the parser generates code right now, but I'm working on pulling everything out to a big AST, and then I'm going to generate all of the nodes. But I'm kind of doing it like one step at a time. It looks similar to Bison. Yeah, I mean, I just did it this way because it was easy to parse. Or sorry, it was easy to lex. I didn't have to like count brackets and stuff like that. If I did it this way, you'd have to like count brackets. Do like a special block scope thing. And I didn't really want to deal with that, so. All right, so when we write the type declaration, we will also generate an array for it, for all the struct types, I think. Says I'm your biggest fan. Yeah, you're my #1 fan. I think it resets every time. It's like whoever chats the most gets that #1 thing. It's kind of weird. I don't know if there's a way to turn it off, but yeah. Well, I don't know if I can do this because I might need to pull the array header into something else. We'll do this. We should do the type name. Yes, we'll do that. We'll do write token. Name. You'll write string, comma, space. What's up now, Chris? How's it going? And then we'll write a list like this. Because this is just a macro that I use to generate array. This is array definition thing. All the streams published on YouTube as well. Yeah, I have a playlist. If you look at my channel, you can watch the old ones. There's a lot in there. There's a lot of very, very old ones. And there's a big gap when I stop streaming on YouTube. And there's also a big gap when I stop streaming, I think too, but I think some of the streams didn't get put onto the playlist for some reason. I'm not really sure why. Is the language blazing fast already? It's as fast as C is. So yeah. I'm gonna make a function for this. I'm gonna call it write array. No. Yeah. We'll do this. Write typed array to the same string, which is like a string builder, and then we'll just do td.as.st.name. We do name. We do name here. All right, that should generate these. However, this needs to be hoisted all the way to the top because this is what holds that macro definition. In fact, a lot of these might need to get hoisted up. I'm not sure. You have a mascot already? Every good language has a mascot. I don't have a mascot yet. Maybe a beaver in honor of your build system. Can I do multi-line strings in C? What is it like a... Oh, I would have to... Oh, I think I can do multi-line strings in my language though. I just don't know how they're gonna emit in C. Let's see here. Or what I might do actually is this. I might do, here's what I'm gonna do. Epic. We're gonna do a file print at the very top to the file, like the output file. And we're just gonna do include runtime.h. Oops, this needs to be escaped. So we'll make a runtime file, which will just have all of these macros. Because the problem is when I hoist all the types, they're getting hoisted above this, but they depend on some of these things to exist, so that doesn't work. This stuff needs to get migrated to the new hoisting system. We're gonna do that, and we'll go runtime.h, and this will be that. And then this array is, I think the array is local to this package. So I think that that's correct. Okay. That's just the array, declare array syntax. All right. Let's try this. Implicit declaration of Malik Carr. Yeah, it's not being emitted correctly. Boom, boom. Oh, this is where it sucks to this is where it's hard to have like a to have the compiler update itself, because my current compiler doesn't do this, but I'm trying to compile this into it. So I've got to compile the new compiler so can compile this. So I might do this for now. Let's see here. Struct type depends on fields. Oh, this isn't getting emitted yet. Yeah, I'm in kind of a conundrum here. Let me think. I might just manually fix these. Until it compiles and then use that. So let's just manually patch these issues. Field list. We have one for args as well. I gotta be more careful. You're running a compiler, what's the intention? Is it just for fun, or I'm just kind of learning and having fun with it. I'm not super I'm not really like building a language. I'm just trying to like learn. But if it gets to that, I might keep going. I'm not sure. I'm just kind of exploring right now though. Args has incomplete type. Oh, because I don't have the expression list yet. We'll do a struct expression bracket. Okay, we're getting closer. Also, what do you compile? C assembly bytecode? I compile to C currently. It's just easier. Okay, I don't want to mess this up though. Let me I'm gonna copy this just so I have it, because we know this compiles, right? And then I want to try to, I think this has all the runtime stuff in it, right? That gets emitted. So we're hoping that we can generate the right output.c file right now. So I mean, technically we want to run this. Make validate. Um, runtime.h. Does it compile from Dash or to learn existing one and try to upgrade it? I read that book, Crafting Interpreters. I went through that whole book, and then he has like a C compiler, which compiles to a VM bytecode. And I'm kind of adapting the front end of that into a custom language. What could this error possibly be? Oh, it's because there's a semicolon here, I think. Nope, there's not a semicolon. Because this one works. Oh, there's this, I'm missing the semicolon there. That's what it was, I see. All right, when we write the type declaration, we're also generating the typed array with it. However, we need to do this beforehand. We need to terminate the struct, and then we can do that. Oh, this is where we need the, we need to go revert. And we'll revert that. And then we'll do make build to make compiler 2 again. And then we can make validate. I think this needs a new line though. Oh, it's not doing the semicolon. What I really should do is this. We'll do output in the make file. I'm not going to build it. Make build, that should work. Now we have compiler 2. All right, this is the output code. Did I mess this up? Write struct type, and I do a new line. It's weird though, because this shouldn't be rebuilding compiler 2. So we should be able to try to compile that. Let's just try to fix these things. Oh, the problem is it's gonna wipe every time. Let's do a new line here. See, I don't know why this is reverting back Oh, because it's using compiler 2 still. Let's go ahead and do this macro. Hold on. Macro, declare, array, go back one again, semicolon, down, down, and oh, I wiped all that, shoot. We need to not in the validate. In the make file, validate. We don't want to regenerate this. Okay, so we're just compiling to compiler 3. Error unknown type name token list. Did I do these backwards? Oh. I know what it is. It's because in migration, we need to write a forward type def. Because we have to type def this array. I think trying to get my compiler to be in my language as soon as possible was kind of a mistake. Bum, 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 bum. Let's see. I'm gonna do this actually in the runtime. We have array. I'm just gonna throw a type def up here. Or type def struct, yeah. I'm just gonna manually build one of these. Type def struct this, and thank you, Sed, for the follow. Appreciate it, man. Welcome. Yeah, wait, where do I declare this? Or it's gonna be struct expr bracket. Oh. Because it's not a struct, it's a man. so many little issues. Parse func. Unknown type name. I don't understand because I have this. Oh, it's because the type gets completed by this crap. Everything's just so out of order because I'm like, I haven't hoisted everything. I've hoisted a lot of stuff though. So like you hoist one thing, but then it's like this thing, it depends on it. Also needs to be hoisted now. Or this needs to know about like some of these. So we'll put this here. Field list. Oh, conflicting. Symbol list. I don't think I need that either. Right typed array. That needs a string. Okay, we have compiler 3 now, which should emit something close to what we want. Let's copy this again. Shoot, I might backup compiler 3 now. We'll backup compiler 3. Let's open our make file. We'll do this. We'll do compiler 3.bin. Source migration.txt. And then we'll try to do GCC output.c. We're just gonna do compiler 4.bin. Okay. Make C3. Yeah, it's just hard to fix everything in one shot. So expressionless isn't emitted. Well, hold on. We don't want these. These ones we have to manually hoist up. And then we write the type declaration. We also want to do it for union types as ut.name. But the problem is that doesn't fix this thing. There's another one. Yeah, this needs a str. All right, our goal is to make compiler 4 fixed. So we need to go through and or wait, hold on. Don't I have a fixed output? All right, so the question is, will compiler 4 give us the right thing now? Line 0. Actually, I might just do this. Copy, what is it? I want to copy this one. This will rebuild compiler 3, and then we'll build compiler 4. Make C3. Unless I messed up. Oh, whoops, wrong folder. Out. There we go. Then we make C4. What do we have missing? Oh, we can't even compile. But I thought oh, I still have to manually fix this stuff though, if I'm... I have to fix this though. Hold on. I actually want to do this. We'll hoist these functions up. We gotta get rid of the symbol list stuff. Write forward type def. Oh no, we don't need this because we put that into the macro. Okay. Now hopefully compiler 5 can do most things. I think that we still need to hoist, we'll still have to hoist those function pointers manually. Okay. Yeah, I really have to be more careful with making these breaking changes. What I need to do is I need to do like big, I need to do all the fixes for the compiler in terms of the old compiler. And then I need to migrate to the new one as like one big switch. I use Arch Linux and GNOME 3. What is the name of the language? I don't have a name for it. Okay. Wait, you're making a programming language? You haven't thought of a name yet? No. I don't know if I'm making like a official programming language. I'm just kind of like learning and exploring. Yeah, so we have to hoist these. All right, hold on, let's comment this out. Yeah, these ones need to be put into here. Right here. Right forward type def. Oh, I need to fix that in migrate. All right, we have the two things we have to fix. Oops. These need to be written here. Okay, that'll hoist those up to the right spot. Oh no, they can't, can they? I need to do this. We have the type. Unless I write them to this output. Yeah, let's do that instead. Okay. We'll do write to type def output section. That string. And the string. There was that, and there's this write forward, or write typed array. There it is. We just need to remove this. Oh, hold on. Make file. I feel like I'm gonna blow this up if I do this. Maybe I have to do it and then fix those two bugs, and then I'll have it though. What's the name of your text editor? It's called Emacs. All right, better safe than sorry. I will do C5. And then we'll comment this out. It's up here. EMACS. Okay. We got these ones. Okay, I think this should work now. Let's make our validate use D6. Okay, cool. All right, cool. So now our compiler is back to being able to compile our compiler. Gosh, what a pain. I really need to think more ahead of how I'm gonna migrate features. Because you do one breaking change and then now you're just, like that was a painful one. Okay, let's stick with compiler 6. We're not gonna rebuild compiler 6, but we'll do, I think I just need to make sure that this always builds. That make validate always works. Let me stage this. Those are just backup files. Hoist. More types. Automatically. Thank you, buddy. Welcome. Thanks for the sub. All right, so compiler 6 is our current compiler. Now we can make a few more changes. Let's see what we got. So we have our runtime file, which is really nice because now we can just throw any C code that we want at the very, very top. Then we have our hoisted type defs. And then we have our hoisted, well, these ones are, we can fix that. New line, oops. I'm in the wrong file. New line. These ones are manually hoisting because I don't have function pointer support yet. We can fix small stuff like that, but if I make a big change, I just have to be more careful. Okay, then for every struct, we complete the struct, and then we declare an array for it. That way we can use everything as an array, which is kind of a hack, but I need to make some more, I need to get some semantic analysis in here before I can start doing more complicated stuff. So we'll just generate a ton of arrays, even though we don't really need them. And then I also really need to clean up the code gen because it looks really nasty. Let's look at our to-do list. To do. Oh yeah, we're gonna we have hoist type definitions. Hoist complete types. One thing we don't have is if a completed type depends on another type or its completion, then I don't sort those yet. So we'll have to do that later. Type defs break up a lot of those issues, but that still could happen. All right, let's hoist function prototypes now. This is going to be another little bit of a problem. Just because we have these ones that exist, and we need to get rid of these ones to get the new ones. So we might have a little bit of issues. We might have to do another compiler migration. All right, let's look at the function parsing code. Yeah, cool. I do it this way. So I generate a function type. Let's add another symbol to our parser. Or I guess I'll do this. I'm gonna use the same symbol list because eventually I'm gonna make it a symbol table based off of the name, because all the names for types and functions have to be unique inside the same scope. So I'm gonna add it to the symbol list, which means that well, first of all, it means the func type. Struct type. The func type needs to be unioned with these. Func type. This is some terrible naming convention, but I also need to clean up how unions operate, but whatever. All right, we got our function, and then we'll just push that, kind of like we do for like struct decal. Oops. Yeah, let me just think here. Okay, yeah, function. All right, we've got our function calculated. This is like the local code generation, which I eventually need to pull out as well, but we need to make a symbol. I don't have a type inference, so I have to manually specify all of my types. And then we'll do sim.decal equals func type. I'm sorry. We need to make a decal. RTD, TD, type, decal. And I do have to manually set these things. All right, so let's set the tag to this one, and then we'll set the union value to func type, and then we'll set that there, and then we'll push the symbol. This should work. Okay. You're creating the compiler in C or Go? I'm creating the compiler inside the language itself. The language itself looks a lot like Go though. But what I do is I have these C blocks. See this like at C section? This lets me just like in place put C code inside of it. Because what I generate is C code on the outset. And then this is the language. So this gets parsed and generates code. Like an enumeration, for example. But this is just like C that's going to get dumped into the output file. And then, yeah, so now our symbol list has functions. So then when we're going through here, this is for type forward declarations. So we're not going to handle function types with that. Then this is going to be write type declarations. I can just add functions here. Write function type, string, td.as.ft. And I will write this. So that'll write the function prototype. Because functions don't rely, they don't need to have the completed type or anything, so we can just put them wherever. Though all that to do here, to do maybe these belong in a different section. Because kind of how it's going to emit is it's going to do type defs, completed types, function protos, global variables, and then completed functions. This seems like the most, this seems like the least amount of sorting required. Because no type def depends on another type def. Some completed types depend on other completed types. No function protos only depend on type defs. Global variables depend on all of the completed types. And then completed functions depend on protos, types, and type defs, and global variables. Oh, sorry, I saw your message, but I didn't read it in time. Because it got deleted for some reason. I'm happy to answer any questions. If you got them. Okay, so this should do function protos, but they're getting put in the completed type section right now. But that's okay. There was one other thing. There was one other thing. I can't remember it though. Right function type. Oh, that's what it was. Right now the right function type doesn't take in the string that we want to write to. Let's go here, hold on. That'll be output. This is like a string builder. Yeah, I pass a pointer, I'm 99% sure. Static declaration of type expression follows non-static declaration. So that's where this is the issue. So these need to be removed. But now we're in this circle of like, or no, I think I can do this. Yeah, this is where it's like, this is where it sucks. Let me show you this. So I have my compiler called C6 right now, which doesn't hoist the prototypes. And I want to compile like the next compiler, which would be C7. Well, yeah, shouldn't I be able to do this? Hold on. How long do you work on your language compiler? I haven't worked on it that long. I've maybe done like 2 weeks of like random little off and on times. But I've spent time learning about this sort of stuff. Like I read that book, Crafting Interpreters, which is pretty good. Yeah, C6 doesn't hoist function prototypes. But then I should be able to do this, right? I should be able to do this. Compile C3, but then C3... Yeah, so let's do this. I think here's how I want to model it. I'm gonna call this build C7. And C7's for compiling C7. And then I'm gonna go down here and just do validate. I'll just upgrade that. So we can make C7, and I'll change that to C7, and then we'll do validate. But with the validate, we want to get rid of these because now we're hoisting these. Oh, it's compiler 7.bin. Make C. Oops. All right, make C7. That way, if I need to fix stuff, I can fix it easily. Oh, see you, buddy. Sorry, I didn't understand what your message meant. Okay, then we can comment these out because now we're hoisting them for C7. We'll do validate. Oh, some of them we don't hoist because they're still defined by C. And it looks like parse rule is one of those. Looks like parse rule is that one. Okay, so now we're on C7. Now if you look at our output.c, we've got like our type definitions, we've got a runtime file, we've got our type definitions, we've got some manually inserted ones, which are these two. And then we've got all of our completed types. And then we've got all our function prototypes interspersed with them. I'm gonna go ahead and just chunk it out anyways with C7. That way it's just gonna be in its own little section. So we'll do write function prototypes, write func. I might be able to do this, hold on. So now we write type declarations. We don't want to handle the FT type. So then down here, I might just do a switch on a single type. Sim .decal.tag case, or actually we just do this. So now we're just writing the function type, and then we'll comment out this one, and that would get rid of this to do. Oh, this needs to use the right type def output. All right, cool. Now our output.c should look like type defs, completed types, all the way down until we have functions. This is all the function prototypes in one big chunk. What's your programming background? How long have you done it? Do you have professional experience? Yeah, I worked as a programmer for like 10 or so years, like professionally. I started with like device drivers and like low-level stuff. I was actually originally a double E. I was an electrical engineer at first, and then I moved into software because I enjoyed it a lot more. And I mostly always wanted to make like video games. So that was kind of like what my focus was. And most of the time when I stream, I make a video game called Mythfall. But I'm also interested in programming languages recently, so I'm kind of exploring that a little bit. All right, we have nice chunks though, at least. We're getting closer. I will clean up the emitted code because it looks really nasty, but it's kind of hard when I don't have all the right features in my language yet. So Okay. Now we've got pretty good hoisting. We've got function prototypes. Oh yeah, there's also global variables. And those would be in var. Well, we've got declarations. Yeah, if we find a variable declaration, we'll hoist that as well. It does feel a little silly. Like, I'm pretty sure I could put global variables and function protos in the same area. Yeah, one could sure tell you like low-level Arch Linux Emacs ID, lots of procedural programming stuff. Yeah, I just like, well, it's funny because I mostly program in Go nowadays. I think Go's a good language though. I just like simplicity. I'm like a very like minimalist type person. So I like simple things. I like simple ideas. I like simple orthogonal concepts that you compose into like more advanced things. I'll make this faster eventually, but for now I just want them in the right order. Because we're doing like the same loop like 1, 2, 3, 4 times. But this will be for global variables. That's like the last thing we need to hoist. And then the rest of what we emit is just going to be functions. Thank you, Vinny. Thanks for the follow, appreciate it. Could you go simple when possible with 2K lines and give code in a file? Yeah, the problem is I don't have multiple file support in my language. It's on my to-do list. It's actually like the next one after hoisting, because I have to hoist. You have to hoist before you have multiple files. Otherwise, you have to have like files have to know the order in which they need to be imported. But once we have multiple files, we'll be able to do one directory that has several files in it, read it all into one big source block, and then have one symbol table for that entire package, because I'm going to do folder level packages. We need to hoist global variables. That'll be the last one. Then we'll do multiple files. I got my to-do list. Let me be right back. I'm going to go get some water really quickly. All right, sorry about that. We're back. Oh. All right, buddy. See you later. Thanks for stopping in. I actually think global variables need to go after function prototypes. Because if you have a global variable that's equal to the result of a function, actually, I don't even know if that's allowed in C. All right, let's hoist the variables though. They belong at least before every function, so. Yeah, declaration, var declaration. What is this? Oh yeah, so we need to know if it's global or not at parse time, because all the other ones I don't really use in inside of function. Oh, let's see who calls this. These might be a little bit harder than I originally thought they were going to be, though. Yeah, because inside of blocks, I either have the parser have a mode. I think I'm going to do that. I think I'm going to have the parser have a mode that tells me like the scope or something like that. I'm not sure exactly how I want to do it, but I think that that's something that'll be useful to track. I don't know if I put it on the function or if I put it on a block though. Let's do a stage though. We'll leave this. I'm gonna delete these. Because I think I feel pretty safe now. Oh, wait a second. I'm literally just emitting these twice. Okay. We'll do that, and then we'll do parser struct. We'll also track, I could either do scope depth or yeah, I'm just gonna do that. We'll just track that, and then because pretty much whenever I do this, whenever I do a function declaration, I'm just gonna do parser.scope depth plus plus, increment it, and then I know that everything I'm doing after this point is deeper in scope. That's one question I'm not sure about. Whether I should do this at the function or the or just a block. But we can always refactor. We'll just keep it here for now though. Okie doke. And then I might split this off. I might do var declaration. Or no, I'll just look up scope depth here. Consume a token identifier. I don't know why that's. Must have an initialization expression. Do default values. I think I'd actually do this. This is the code gen portion. So basically parse the variable name. Then the variable type name has to come after. Eventually I'm gonna make that inferable. And then we match, if there's an equal sign, we look for the expression. Otherwise we just consume the semicolon. All right, let's make a node for this. Let's make a node for this. I don't like that this is called type declaration. It's more like statement, but it's not really a statement. I don't know. Oops. All right, we'll build a variable declaration, which is gonna have the name token. It has the init expression. It has the, I'm sorry, that's init expression. We also have type expression. All right, they'll have a type declaration. Then I'm gonna make a function that's gonna be called write var decal. VD var decal. This is like the codegen portion. Output gets converted to a string, and I think this needs to be vd dot type, because the type goes first in C. Then vd dot name, and then vd dot init. This is the init expression. If it's set to none, then that means there's no equals. vd.init. Well, I think write expression. Does that take a? Oh, that takes the string. Okay, good. Otherwise, it goes to a default value, and I guess I just do this. I don't know why though. I'm not writing anything, so this doesn't do anything. All right. This will do the variable declaration. I want to hoist these up though, like to write union type, for example. I want to put these all together. Write union type, write forward, write type forward declaration, write typed array, write type declaration. What's up, Palaris? I hope you're having a nice day as well. We need to do a declaration, var declaration. We just need to build this thing. Var decal, and then I'm just gonna do vd. vd.type equals type name. vd.expression equals expression. And that's it. And then we just do, to keep it the exact same, we would do write var decal to output vd. That should compile. Oh, it's not called expression, it's called init. It's the init expression. Okay. However, we don't want to write it here because that would keep it in line with all the functions. We want to put it at we want to hoist the global variables as well. I did forget to, or no, here's what we're going to do. Because we added the scope tracker, remember? I don't remember what I called it though. Scope depth. If parser.scope depth equals 0, hoist global symbol table, else write immediately in function. Oh, one thing I did forget to do is we increment it here, then we decrement it here. All right, cool. Okay. I think this is good. Now we got a symbol table, or these will get added to our symbol table. And we'll go on the sim.decal.as.vd. I think that this writes a semicolon though. Yeah, because expressions, right? Okay. Okay, that should hoist our types. It doesn't seem like it did though. Bum, 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 bum. Oh, am I adding these to the symbol table? I'm not. I'm building it. I wrote even the note here. I can't even remember what I call it. Parser. Let me just copy this. Sorry for the weird syntax. I just don't have composite literals yet. But once we do, oh boy, oh boy. I really probably should have added those sooner, because I don't think they're that hard to do. Oh, whatever. Kind of an annoying amount of things that have to be built. Okay, there we go. And then we should see in our output all of our function prototypes, and then we should have all the globals. Yeah, they're not putting a new, there's not no new line yet, but at least we see all of our global variables are there. We can add the new line though. Cool. There's all our global variables. This was a backwards compatible change, so we don't have to do any migration things. Let's get rid of this. We're slowly like separating out the codegen portion from the AST parsing. Okie doke. All right, I just want to stage it all. Hoist global variables. Are either multiple files or compound literals? The one worry I have about multiple files is I don't sort complete types yet. Let's do compound literals. How hard could it be? Luckily, we have no compound literal syntax, so it's not like we're moving away from anything. We're just adding this. That means we do have to decide what we want it, how we want it to work, though. I mean, I'm probably just gonna do what Go does. I also need to migrate away from I need to migrate away from what's it called? The different expression types. If I could find them, here they are. We'll think about that once we have compound literals, I think. I can get rid of all these. I think how this will be modeled is we'll look for a left brace. It'll be an infix operator, because it'll be something like this. It's going to be expression, left bracket, expression list, right bracket, plus a comma. And then it'll be like my struct 5, 6, 7, for example. I do need to remember how compound literal syntax is in C. C compound literal syntax since C99. They do parenthesis type name, then they do initializer list. Does this work everywhere? Because I seem to remember there was some places that I couldn't do this. But I'd rather have one syntax than two. I think the other syntax is you just do this. And because you know the type, it's kind of implied what the literal is. Like this is the type's here, and then the type's also here. All right, we'll do something like that then. we won't require the parentheses because we have a way to parse. One thing I don't know. We'll just have to see how the precedence works out. I think it's gonna be the same precedence as a call expression though. Let's go to this one. What did I call it? Complet? We do need to make a new expression for this though. So we'll parse the argument list until we get the right brace. And then instead of a new call expression, we'll do new complet. Call complet. Oh, it's called expression call. What's up, Rubiel? How's it going, buddy? I'm doing good. I finally bootstrapped my compiler. So now we're building our compiler and with our compiler, which has led to a lot of pain, but I think I've finally figured out the right procedure for it. Every time when I want to do a backwards incompatible change, I just upgrade to a new compiler version. That way I have like a tree of compilers going from the start to the finish. And yeah. So if I ever need to like go back, I can. Not that I ever have to go that far back, but sometimes I'll make a change, like break my current compiler, because I was compiling to the same compiler. I was looping back. Like I was doing this. I had my compiler, and I compile to the same binary location. So I'd just be recompiling with new code. But then if you break this with a bug, now you're like stuck. So what I do now is I do like C1, compiles to C2, compiles to C3, compile to C4. That way when I'm always like building a new thing. And yeah. Okay. I feel like a complet or a composite literal is almost like a call expression, except for the fact that the function just returns whatever the type is. So the callee is really going to be like the type, I think. Yeah, I'm happy to have figured it out. So we'll do a new complet expression. The left is the callee, but it's also going to be the type. And here I'm going to treat like the type. We'll look at this function and do that. Hold on. Yeah. And this is the arguments. And then we have our, we'll make a new tag for this. And then we also need to make a, we need to add this to our union type. And then I have a function that's like write. Thank you, buddy. Yeah. I'll try to keep it up. We'll see where it goes. I don't know how far I'll get with it, but I'm going to keep doing it till I get bored of it or tired of it. But maybe I never do. Who knows? Okay, we've got our right type expression, and then we'll add this. This is code generation, so it's always looks a little weird. It's going to be similar to a call expression. We'll write to our string builder a left parentheses, then we'll do a right parentheses on the other side. The callee is going to be the type. I'm torn about using ty. I might change that, but then we do a left brace. Then we do this is our initializer list. Then we do our right brace. Oh, oops, I messed that up too. I really need to fix this stuff. Like, this is why we're fixing this, I guess.
Well, here's the sleep shop's answer.
Oh, I probably messed up the this. Yeah, I definitely messed this up. Okay. Can you name any function what you want, like printf to show text? Yeah, I could. I mean, like how it works is I have my language that compiles to like C. And then if I want to write a function in this, or right now I just import the symbols from like the standard stuff. Like if I go to runtime, like I import like all the basic stuff that people usually use with C. And I have a few macros for things, but I can call all of these functions. Yeah, if I wanted to write a new function that called printf, I could do that. Like these are all functions written in my language. Not that it's like my language because it's very inspired by Go, but It's a work in progress. All right. We need to build the next compiler before we can. So we're able to compile the compiler, but then the new compiler isn't working for some reason. Line 0. Error semicolon, expect right parenthesis or I'm just trying to see what the complet generation looks like. Oh, this is probably wrong. Because we want to write the type expression of this. Oh wait, but why is it parsing a complet? I don't understand that. Like, where is it finding one? That's the real problem, I think. Let's go ahead and add I'm just gonna throw an error here. Yeah, so we found a complet. It thinks it found a complet. I'm just curious where it's finding it. Line 156. 156. Left brace. Oh, I see now. This is ambiguous because it's seeing this bracket and it's thinking this is an expression. Therefore, this must be a complet. Because this is an expression. The problem is it's an expression inside of an if statement. It's an expression inside of an if statement. Like the problem is the brace is part of that. So I need to disambiguate this somehow. Let's look at the if statement. Like we parse this expression. Parse precedence. What was it for a prec assignment? Yeah, I think the main thing is when I see this left bracket or brace, I guess. When I see the left brace, I need to be in a mode where I'm not interpreting complets. I wonder if what I should do is just have the parser have a mode where it's like blocked complet. And then when you look for when I look for this infix, I'll call it like parser skip complet, I think. And I think in here we'll if parser.previous hold on. Yeah, it's hard because these don't have that. I wish I didn't do function pointers here. I guess I could migrate that. Because I mean, basically what I'm gonna do is I'm gonna say if parser previous equals token left brace, then I'm gonna continue. No, I think I need to break. Or hold on. So if we're in skip comp lit mode, and the current thing as a token left brace, then we'll just break and then return whatever expression we have. Because we'll only be in skip comp lit mode whenever we're doing like a for loop or an if statement. And pretty much we want to do parser, true, false. There. There. And then switch has one too. Has a bracket. Return doesn't have a bracket. For loop must be somewhere though. Yeah, for loop has it. Rewrite my lang in itself. That's what I'm doing. It's pretty it's fun, but there's also a lot of pain. I'm gonna do this. Skip complets all the way to the body. Error at left. Found complet. I was working on my type checker. It's also a pain. Yeah. Yeah, I did a first draft thing. And I also did like a kind of a type checker, but it was so broken and botched. I was like, oh boy. Type checkers are hard. But now that I've written one kind of crappy version, I think I have a better perspective on how to do it. Or I'm hoping I do. There's a lot of things you don't think about, like recursive calls or like functions and functions, or just like weird referenced things. I didn't really have like a proper symbol table because I wasn't sure that I needed it. You have to do all that scope hopping. But yeah. Oh, 177. Huh? Oh, it thinks this is a complet. Boom. There's got to be a better way for this. I mean, this one I know it's a function return type, so it must be a type. Let's look at our function. Our function. Yeah, I think for type expressions, I'm gonna skip complets. Okay. 166. Currently handle everything on one table. Since it is more issuer and more reliable to do it that way. Also the language is small for now. Yeah. I gotta imagine a symbol table Oh, a single symbol table for all of your globals is super duper scalable. Like, how many global symbols could you possibly need? Like, I feel like adding like thousands of things to a table doesn't take that much. And I can't imagine having like more than on the order of thousands. Like having 10,000 symbols seems like a lot for someone's program, I mean. But maybe that's not true. Maybe that is possible. I guess for a big enough program, maybe I could see it. Like if you have a big constant array or something like that. Just wondering if you need scope, have a parent in the child table. And set it if you need to do stuff like shadowing and checking for identifiers there. Yeah, and then you just walk up your symbol tables, depending on how far nested you are. That's what I did in my first one that I wrote. All right, where's this error? 166. It's in 4 statements for some reason. It probably thinks this is a complet. 4 statement, skip complet. Oh, I just realized something that's super. Like if I ever call into something, it could clear it. So I need to increment the complet skip. Let's look at where we use skip complet. Skip complet. 4 statements, type expressions. Yeah, so what probably is happening is the var declaration parses a type expression. If 0, allow. All right, so then we'll just increment and decrement instead of setting it to false. All right, let's go through. If skip complet equals or is greater than 0, oops, I almost did that backwards. That's the stuff that gets me. Okay, so if it's greater than 0, that means that we are not allowing them. So if we see a left brace and we're in a skip mode, then we won't continue parsing. All right, 1081. I know there's a command to go to a specific line. I don't remember what it is though. Else if. Or we'll just do if statement. Figured out. Yeah, I figured out I would need to use both RSA and post-quantum encryption, but then RSA will invalidate the post-quantumness of. Now that I think about it, writing that, I realize not necessary. Just need a selection. Yeah, I'm not familiar with quantum encryption, quantum safe encryptions. If, oh, that's a switch statement. Where'd we go? If statement. All right. Else if, oh, I put this in the wrong section. Because this is the writing, this is like the code gen part of the if statement. There we go. Now we should have, at least we're not completing on for loops and if statements and switch statements and stuff like that. So basically when people log in, they choose what they use. I see what you're saying. That's cool. Isn't there a I'm trying to remember what it was. There was something, there was like an OAuth, like it made sense when I was reading about it or when someone was telling me about it. But there was like an OAuth replacement idea where the person would like authenticate themselves with a passkey. Oh, maybe they had a password to generate their private key that then could be used to like identify who they were on your website. I thought that was a cool idea. Because then you don't need to have OAuth. It was something like that. I'm probably misremembering some of the details. What was it called? Yeah, I don't remember. I genuinely cannot remember what it was called. Let's add to our make file. Validate. I'm gonna run the compiler on on test.txt. And then I might just do tcc run. On it. Cool. All right, let's go to our test file, just because sometimes it's easier to write tests, little tests here, than it is to write them in the compiler. All right, let's do a composite literal. We'll do like point var p point equals 0.12. I think I did two things. Yeah, two. We'll do printf. And we'll do %d %d p dot x p dot y. Oh, error at this found complet. So it found the complet, I think. So the way you're doing it is the same concept as a one-pass compiler. Once you encounter a token, you translate it to its equivalent C, right? So I based it off of the crafting compiler's single pass bytecode compiler. So when he did it, he generated bytecode immediately, and I'm slowly moving it out to parse like statements and AST like nodes. So like it's kind of a mix and match right now. Like for example, statements all emit their own C code. But like when I parse an expression, it gives me an expression. And then I have a generation function called write expression, which knows how to write every type of expression. So like eventually I'm slowly pulling it out to an AST, and then I'm gonna do code generation at like the back end in like a more proper way. But like for some reason I wanted to self-host as soon as possible. So I did as minimal as possible to get to the point where I could generate C code, which I kind of regret. What I wish I did was, I wish I did the Lexer parser to an AST and then did code gen. And then I wish I just migrated everything at once when I had like mostly everything in place. A type checker is just a pain, so I didn't want to write that in C either. But it leads to a lot of like weird types of code. Like every time I establish a variable, I've got to specify the type afterwards. But like once I have a symbol table, I could be like, oh, op is parser.previous. So I want to move to this, but I need to be able to know the type of this before I can infer the type there, you know? So I'll have to move this syntax. I'll have to add this operator once I've got a type checker, or at least some kind of type system. So I'm just like slowly adding stuff. What compiler is this? Is it on GitHub? This is just a custom language I was kind of working on. My objectives are kind of like a very small bump on top of C towards like a Go-like syntax. So that's kind of what I'm building. And then like maybe more emphasis on like arena allocators. I'm not going to do a GC. I might do reference counting for like more nebulous lifetime, or data with more nebulous lifetimes. But yeah. But yeah, I'm not like building a language. I'm just kind of like learning and exploring. Like it could not materialize in anything, but I also could maybe stick with it because I just don't know how I'm gonna keep enjoying it. Like I might get to the point where I'm like, oh, I love this language way more than Go, and I might just start using it. I also want hot reloading. That's like a big feature that I want to have. I didn't study in university, but there's this book called Crafting Interpreters, which I highly recommend. It's free. It's on the web. There's like a web page you can go to. I can send you a link if you're interested. All right, let's go look at the output. It did generate a complet correctly, but it didn't generate the print function. Like this looks like a correct complet. I wonder if, oh, I think that it doesn't detect a semicolon here. Would I need a semicolon there? Like I'm trying to think of why this line isn't existing. Oh, I know what it is. Because I use that error message to print where complet. I put this error message, but I think if I recall correctly, this sets the compiler into like a panic mode. Yeah, it sets panic mode true, which then causes the nothing else to parse until it finds a new sync point. So once we remove that, it should probably work. Print F, expect semicolon after variable declaration. Yeah, so it's not inferring the lexer. It's in, sorry, I forgot I put all of this into one file. It's gonna be called infer or imply. We'll do right brace. Which is a little bit of a weird one. I think this should work though. Type checker is useful to have. I was going to support the walrus operator to infer the types because I already have the logic for inferring the types. So I might just add it in the upcoming days. Yeah. Yeah, I definitely want that feature because I forget how verbose syntax like this is. I wonder, have you looked at like Odin type declaration syntax, like Odin or Jai, how they do it? Packages. I didn't want to go there. I wanted to go to like getting started or like documentation. Books. I swear there's gotta be is it this? Overview? Oh, it's an overview. Okay. Variables. Like you just do like this. I guess he does the walrus as well, never mind. For some reason I thought there was a way. But yeah, you don't have to have the var keyword, which is kind of nice, but I don't know. I'm torn. I'm always torn on syntax. I do like very readable code. Otherwise it would be like this. It'd be like token or something like that, I think. Yeah, it would be like this. The problem is the Go LSP thinks it's a tag. For myself, I like to be explicit when typing. This is also explicit. It's just that instead of doing var token, you would just do token as the variable name. So I didn't want that, yeah. You do the token name and then you do a full colon to say it's a variable, or you do a double colon to say it's a constant. But yeah, I don't know. Okay. Output.c. What was the last thing I changed? Oh, I had that. Okay. I find it a bit unreadable when it comes to type aliasing. Oh, I see what you're saying. I was gonna do the syntax things I saw it call. I was gonna do the syntax thing because I thought call the one for structs and enums, etc. in Jai. Person human is a bit unclear. Yeah, I do like I like the upfront, like, oh, this is a type declaration, and like I'm aliasing scanner to like other scanner. It's like, okay, this type is then this one. Though, I don't know, equal maybe makes sense. I don't know, I feel like Go did a good way. Like once I understood it, but it's kind of, syntax is very opinionated, I guess. I do need to imply a like that fixes it, having a semicolon there. Here's what I'm gonna do though. I'm gonna go ahead and add this back. I just want to do this. I want to do I just want to do a quick test. Compiler 7. Oh wait, but that's not, I'm not gonna have the right one, is it? Yeah, we'll just do this. This is the wrong token. Token left brace. Yeah, your way is good because the code directly says what it is. And that's something that's always good to have. Yeah, it is a little bit verbose sometimes, but I feel like it reads easily. I don't like languages that end up being very terse, where it's like a bunch of different symbols and it's like, what is this? Like, what does it mean when there's like a single like a single one of these, you know, for like lifetimes in Rust, or like if you do like a question mark, what does it do here? You know, I like very like simple syntax. I'd rather a short word instead of like symbol soup, you know? Yeah, Rust has a lot of symbols and I just like see it and I just can't immediately parse it. Like none of my intuition from other languages like transfers. Some of it does, I guess, but okay. It's crazy how I'm it's like infinite looping. Imagine writing a definition for your function in Rust that you use another language through FF. That's real pain. Oh yeah, like translating one to the other. I could see that being tricky. What's up, womanizer? How's it going? Womanize any women recently? Oh, I'm doing the wrong brace. This should be right brace. Silly. Best product placement. Or hold on a second. At line 0, error at semicolon, expect expression. 8,000 is my goal. Nice. That's a big number. But it's good to have lofty goals. All right, let's see. I mean, it's gonna add a semicolon here, I think. Why does it think line 0 deserves a semicolon? Might just be unset or something. Actually, what is this running from? Let me just fix that. Hold on. We'll do a right type expression. And we'll do, I'm just gonna do right type expression. I have 2 of these. This one's gonna be a right expression. So it's in right expression. It's just like, what statement am I even on? Like, is it adding one here or something? I think I'm just gonna try to add a declaration. I think if I see a semicolon, I'm just gonna skip token semi. Is this right? Colon. Okay, that's better. Because it's going to imply a bunch of semicolons on things like this and here. But then I don't really have a way to parse those. So this is just like a random semicolon that doesn't really have anything attached to it. We're writing a parser? Yes, we are. Yes, we are. Which language are we parsing? A custom language. We're writing the parser in the custom language too now. And I just added, are they called compound literals or composite literals? Oh, it's called compound literals. Compound makes more sense, but composite also makes... Oh. It's a Go thing. But in C, it's called compound literals. I like composite better. Ah. All right. What's up, Sounds of Tundra? How's it going, buddy? How we doing today? Okay, we got composite literals. Ish. I don't think we have all the syntax, but we've got some. Let's try this one. We'll try to migrate this C code. Field push list, and then we do a field with field name, field type. Oh, I forgot to migrate the compiler. Hold on. We gotta go to compiler number 8, I think. Dum, dum, dum. All right, and then validate. We want to use this one. Make C8. Okay. All right, C8 supports compound literals. Look for devs who do work outside of what I normally do. You work on the compilers a lot, or is this the first for you? This is like a second for me. I just finished that book though, crafting interpreters, and I'm trying to build a language. Means at C means C FFI call or what? I just use this syntax to throw any C block, any like C code that I don't have like, because all of this is written in my language except for blocks like this. If the tokenizer sees this sequence, then it makes an entire token out of whatever is between here and there. So all of that ends up being one big token, and it just dumps that into the file. So it's just a way to like incrementally migrate away from C, because I wrote the original version in C and now I'm trying to migrate to the custom language. So like, for example, now we're trying to migrate it. Now that we have composite literals, I want to try this. And voila, it works. We have one here too. Can I just paste that? I didn't copy it. Oh well. All right, that should be a composite literal. All seems good. Because there's a lot of places where I do, like for example, this. Like this would be better like this. For example. I think that'll work. Yeah, name and fields. Why doesn't it go back to where I was searching from? So now I can simplify a lot of syntax into one line like that. I could maybe even do a little bit of super simple type inference this way too. Like a template? Yeah, kind of. It's just like a way to, like for example, I couldn't migrate this function because I don't have array indexing syntax yet, so. Bro, I just had a very spicy ramen. My stomach is effed up, bruh. That sucks, dude. Take a Tums. I don't know how much I want to go through everything. I might just migrate composite literals as they come, like as I see them. All right. I always miss this E for some reason. All right. All right, we've got complets now. Why do I want to add those? Oh, just because it was super annoying to do, where was it? I don't remember what function I was doing. It was the one right before this. It was probably variable declaration. Yeah, like manually filling out every single field was super painful. Add basic, composite, literals. All right, let's try to do this one, just to test our. I don't know if this will work. Oh, I don't know how to, I don't know if I have a way to do it for unions actually. Maybe we can't do this. Because this is a union type. And if I want to do any kind of like advanced composite literals, depending on the type of thing it is, I probably need to have a type checker. Like I need to know that this is a union type, not a struct. And then I could infer what, I don't know how I'd do the syntax. Let's not worry about it. All right. Can we do multiple files yet? The only section that's not hoisted properly is the completed type section, because one type might depend on another one. That feels like something that's going to get resolved, that type check time. Because I need like a proper symbol table for that, I think. We can try to fix the index operators. Or we could try to move everything. Oh, let's do the index operators and then like let's just keep removing these at C sections. I think most of them are. Multifile needs a good sim table to handle that. Yeah. I don't really have a symbol table yet. I have a list of symbols. Like it's definitely possible I could sort this. I just feel like when I add a proper symbol table and I do proper like type checking, I'll just know what depends on what. So it's not worth doing now. Yes, we need array indexing syntax. So let's do that next. I thought this worked, but for some reason when I was migrating, it wasn't working. So I kind of gave up. I guess this should work, right? We need to be able to declare arrays, and then we need to be able to index them. Right type expression. I think this is an array expression. Oh, this is gonna be int undeclared. Output.c. Yeah, why am I doing it this way? Thank you, Ledevs, for the follow. Appreciate it, man. Welcome. I mean, what I need to output is I need to do like int index brackets and then expression inside of that. I don't remember. Expression? Oh, union. Bum, 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 bum. Oh, it is kind of backwards, isn't it? So it's a little bit trickier. Because before I could just dump the type out and then do the name, but for an array I need to do Like the array portion is part of the name. Let's look at the variable declaration code. Write variable declaration. Might just do a special one if the declaration is an array. C just has to be so confusing with its... I wonder if there's like an easy way. Generating C generate array syntax. Yeah, I think you just have to put this after, unfortunately. Okay. So we'll just look for this and we'll do we'll look at the type of this. Yeah, this is just such an awkward thing to print. I guess I'll remove this and yeah, because if we're an array type, then we need to do something special here. Else we just do the type and then we do the name and then equals whatever. But for array syntax, we have to do the type. Right type expression as array, the type of the array, then a space, then the name of the thing, then we have to do the brackets. The problem is something can be inside the brackets, so we've actually got to separate those. And then we need to do write expression, expression.as.array, index expression. So it should do the type like this: int space name left bracket index expression right bracket. And then after that, it does like equals something. Okay. I think this works. Oh, I think I did the wrong one here. This is vd.asArray. Vardecal. Oh, .ty. I think. What about typecasting? Are you willing to support those? Yeah, I will do typecasting. Right now I have a oh, it's in my runtime. Hold on. I just do I do a cast function because I don't have what's it called? I don't have syntax support for this like parenthesized syntax yet. because you can't like, I was going to do this syntax where you do the parentheses. And I think what I realized was that I need to detect that this is a cast operation afterwards. Like in the semantic analysis phase. EXPR. Oh. bd.ty to as.array index. This is another operator I want to get rid of, this arrow operator. But I don't have type checking, so I don't know if this is a pointer. Let me look at test.txt. I wonder if this is printing correctly. Index 45. Let's set the index 45 to 45 equals 45. All right. Index 0, 0, index 45, 45. All right, cool. This works. You can define a set of word and use them as special call functions. Like Go does it. That's much simpler to support, I think. But how do you know? You can define a set of word and use them as special call functions. But you need to look up the name of it to know that it's a type and not a function, right? So I don't have a symbol table to look up to see if it's a function or a name. Yeah, I mean, for simple ones, I could probably just be like, oh, I know like the set of basic types. But for like user created types, I wouldn't be able to do that, I don't think. Also, if it's like a pointer type, if I'm casting it to a pointer type, because that's like the most complicated one I think was. So I made a custom one for pointer casting. So I just call a cast function. Like I just explicitly call cast or cast pointer, and it works. But yeah, I see what you're saying. Yeah, that's how I'm gonna model it. I think it'll just look like a call expression, but on the code generation side, I just generate a function because I don't know. Like I would generate a function that's like int like 5 or something, you know, or like 5.0, like cast it to this, but then like C doesn't know of a function named int. All right, we've got arrays now. All right, we need to move up to the next compiler generation, C9. And then we'll change validate to use C9. All right, we now have C9, make validate. This should have some array expressions. Let's go into our migration. Oops. What is this for? Oh, I'm just gonna do this. Hold on. Arg. Arg name, arg type. All right, that works. Okie doke. At C. Is that the last? Oh no, it's not the last one. All right, let's look at this one. Let's try to move this guy out. Func returns a character. This is fine. And I think this should work. Invalid storage class. Oh, whoops. Select our peak next. I don't understand though. Oh, maybe it needs a semicolon here. No, I think I must already have that, right? Oh, I don't have right brackets. Oops. All right, hold on a second. Let's add this one back. Does it work? Yes. Okay. Invalid storage class for function peak next. Is this a C error? Oh, it's not adding the oh, it's panicking. Okay. Yeah, it's consuming the right bracket. It's still not in. Oh. I know what it is. We need to do. Hold on. Let's regenerate C9. Okay. Because I updated the compiler, but it didn't add the semicolon there. There we go. Okay, yeah. We didn't have the semicolon being inserted there. All right, that one's fixed. Hold on, let me just comment this whole thing out. Func, this returns a character. And that should work. Cool. One less C block. What is this for? This was my old skip whitespace function. That one took a long time to migrate from. That was like one of the first big functions I migrated from. This I don't have a syntax for array, like a specified arrays like that. This one, however, I think I can do. Func returns a token type. Var count size t. Var I. This is size t technically. Var def. Keyword def. Var ret token type. See what I mean? Like type inference would be so nice here. I'm counting down the minutes. Got our if statement, and then that. I was making a programming language with a .txt file extension. Yeah. I just changed Emacs to think it's in Go mode, so it's like pretty close. It does the syntax highlighting correct at least. I don't have a name. I don't have a name for it, so I just whatever. .txt is fine. All right, this works. Good. Yeah, this one I wanted to have. My for loops don't support single statement for loops, which means I have to like put an if, like I have to do stuff like this. I want to fix that before I do this section though. This we can get rid of. What is this for? Bro, we need a name. Yeah, I don't want to. I guess I could have like a working name. The problem is once it's kind of UOT lang, unit of time lang. I could call it UOT. How's that to type? I could do OT of time. I don't know. Unit. I should just call it unit. Unit lang. Not a bad name. It's very like self-serving though. What is this? Oh, this is because get rule is this should work though. This was one of the ones that when I realized it wasn't working. Nice. That got rid of 2 C blocks. One of the big ones is just going to be array specifier syntax. I was going to say call it E, and then I looked it up and it's already a lang. Is it really? The problem with all just single letter names is we're too far gone in the technology space. All the character are one space, by the way. Each other on my keyboard is easier to write. Which one, unit or UOT? What keyboard do you use? What layout? Are you like is there like a European one? UOT. Mine's 2 right-handed and then 1 left-hand. I use QWERTY though. This loop stuff I want to do once I have loops. Once I've got a single statement for loops. That's kind of a big block. What was this one for? Is that the last one? We got parse rules. All right, cool. Let's do this one. My keyboard is one piece, QWERTY? QWERT? I like how you divide it. Oops. I don't want to lose this in case it doesn't work. All right. Func, token express. Returns an expression. Reverse those. Var, ret, expression equals. Or we really can't do that. We'll just do this. That should work. Okay. Can we call it Golang 2? We'll call it Golang 3. Golang plus plus. Or we should call it Golang minus minus. That's what I should call it. C minus minus. That's gotta be a language. Holy go. Good work. I feel like we have to throw a minus minus in there. Alright, this. Does this work? Oh, I forgot to do that. Expect semicolon after variable declaration. Oh, whoops. Cool. Go C. C minus minus is really the language. Gosh. C minus minus is a C-like programming language designed and generated mainly by compilers for higher level languages. Oh, interesting. That's actually a good idea. It's designed to be generated by compilers, not to be... So instead of generating C, you generate C minus minus. It's a portable assembly language. I wonder if this ever took off. C minus minus is a reduced form of C. It's a funny name, though. Let's see here. It's tightly defined, simpler alternative to C, which supports all of these. Its most innovative feature is a runtime interface, which allows writing of portable garbage collectors, exception handling systems, and other runtime features. It would be nice to have something like this. The only problem is there's so many C compilers. There's not that many C minus minus compilers, so it's like probably not worth it. The fork is called CMM. Or I could call it COG, COG. That's kind of a cool name. Just reverse of Go C. Why not a C assembler? CAS. COG. All right, we migrated some more C blocks. All right, let's try to do this while loop improvement. I seem to remember it being kind of confusing though. While, or no, it's a for statement. I wrote a note about how to do it though. Make this an expression and then convert it to a while loop if needed. Cogling, that's cool. Cog would be cool. Yeah, of course there's already one. 8 years old though. Machine learning models. Only has 1 star though. I think when you make a repo, it stars itself. Could work. Founded by coglang.com. Cog is not too bad to type either. Cog. I like when things alternate hands on my keyboard. See? Easy. Easy peasy. All right, what do I have in this? Nothing. All right, cool. We have a clean git tree, so we can experiment a little bit. Yeah, here it means we were a single statement for loop. Let's go ahead and update our test though. Hold on. Well, I guess we have none of these in there anyways. Let's try to make a single loop. That's not true, man. Most of my repos have 0 stars. Oh, really? Oh, you're right. This was me going through that book. That one's got 0 stars. All right, let's make a single for loop. How does this work? Oh, because we specified up there. It's called crafting interpreters. Oh. I'll send a link if you guys want to check it out. It's a good book if you want to learn how compilers work, and you don't mind doing it in Java. All right, we'll do var int, and then we'll just do. I'm just gonna do count. We'll do for count less than 5. Count plus plus. Printf count to 5%d count. It'll count to 4, I guess technically. There's one with the Dart Lane guy. Yeah. Thank you, Whopper System 1, for the follow. Appreciate it. He's also got another book called like Game Programming Patterns or something like that. Line 48, semicolon, expecting expression. Wait a second. Line 48. How though? I didn't change anything. Or did I change something? Is it that? Oh, it's because I did this, I bet. I think the problem is I need to capture a semicolon. If it's available. Let's look at the output. Oh, I commented this out. Whoops. All right, now we're at 109. Oh. It's expecting an expression. Yeah, but this, so like what I think should happen is the code generation is going to be mega messed up, I think. I might pull this out to like a for loop node and then generate it at the end rather than generating it in line. Let's do that. Because I don't think I can put this into a for loop. Maybe I could just put it in the middle section. But still, this should still parse. What's the errors in? Yeah, for some reason it's doing. Like I should see left brace, I think, and then this else statement goes all the way to here. Oh, it goes to there. Yeah, then we don't match we match the left brace, which is here. If we don't match it, then we loop, or we get the condition, and then we get the incrementer. And then we match it. And then we match it. Yeah, and at this point, we're guaranteed to have gotten to the left brace. Okay. Oh, then we print out all of the stuff, which actually might work for how I do it. Okay, that could actually work. And then we do the statement afterwards. But the left brace is already parsed, I think. I don't think statements do... Oh, where's the right brace, though? Hold on. Wait, how does this work? How did this ever work? Oh, I see. I don't want to match here. I want to check. Because I'm pulling out the left bracket and then it's... Or there, I mean. Okay, let's try that. Count to 4, 0. Count to 4, 1. Count to 4, 2. Count to 4. Oh, it's just looping forever. Mm-hmm. Shoot. Please don't kill my system. Ah, frick. I don't remember which one's which. I don't want to kill the wrong PID. Why can't this close? So dumb. Which PID do I kill? The right one or the left one? Is it left or right? All right, let me know if it comes back. All right, it's the right one, I think. Fuck. Oh my goodness. What did I just do? And it still didn't die. Freaking kill me, dude. It must be this one then. Yes, force quit it. Oh my gosh. Is it? All right, hold on. All right, we're back. Golly. Let's look at the output that got generated for that infinite for loop. I don't know how it got so stuck. Yeah, nothing got put there. It's because it didn't parse the expression correctly. I'm scared to work on this. What I'm gonna do is I'm gonna do this. If count is greater than 10, happened to me once, it killed the system. It's just nutty that that I can't force kill this process. I might run it in a terminal. The problem is I went to kill my PID and I didn't know if it's the right one or the left one. I know one's the parent process and one's the child process, and I think I killed the parent, which was like something in the desktop environment. At least I know which PID to kill now. It's been a while since I've had to do that. Okay, we'll do this now. So if it gets higher than 10, we'll fail. I was probably doing make test or make validate probably. No, it did it again. Why didn't it break? Oh shoot, they're really big numbers now. I think it's the left one though. Let's just Google it. Which PID number do I kill from PS Linux? Yeah, close without saving. Yes. All right. All right, let's see. I forgot to put a break. That's what I get. Yeah, the problem is I'm running it inside of Emacs. All right, until we figure this out, we're gonna do cd git lang. Oops. Is this saved? Okay. All right. All right, we're safe now, I think. All right, we'll infinitely loop now. So that's an improvement. Okay, so the problem is it's either not parsing that middle expression or it's parsing it, it's just not using it. Let's go to the migration, go mode, no, okay. And then we'll do, oh yeah, for statement. Yeah, oh, we need to do, I think this is just all messed up. Like, I don't know why I would check for a semicolon here. But I guess we'll do if match semicolon. So we're going to read the expression. If we match a semicolon, oh, the weird part is the init is, I think I always, what I think we should do is just make an AST node for this. We'll just do that, and we're gonna do, I don't wanna keep the token. I guess it would be nice for printing errors, but maybe I'll add it in the future. So we'll have a init condition and the incrementer expression. And body, which is a statement. I'm gonna comment that one out. Do var. I might just rewrite this. Isn't the body an array of statements? It is technically, but it's also a block statement. Like you can think of a block statement as a statement with an array of statements. So I just think of the body as a block statement. Like a type of statement is a block statement, which can have an array of statements. It's kind of a weird thing, I agree. But I think that it just makes it a little bit more like block scoped. I think it's better to have things in block scopes if they are block scoped semantically. Yeah. Yeah. Okay. I think we'll constantly the problem is these don't return statements. Also, this isn't this is also a statement. The init section. So I kind of need a var declaration to return a statement. Which does it? I did it that way, but I make blocks reusable in a way when I encounter a block, I recall to the main entry point of the parser. Oh, interesting. So I'm just thinking how this is all gonna come together. So this will return, but it could also not return anything. What's the goal of building this language? What are the features or differences between it and Golang? I'm mostly just learning and seeing how it goes. But I just want something lower level that has kind of the syntax that I want. I want better hot reloading support. I want better C interoperability, etc., etc., etc. There's a few other things too. Like I want more manual memory management. He's just trying to impress us. It's all about us. Yeah. Well, you guys don't see the second monitor, which has just ChatGPT telling me what to do next. That's why the long pause is, because it's got us the API's got to send out to OpenAI server. It's got to tell me what line I got to write next, and then I copy paste it. Four. I have to go to the bathroom. I'll be right back. AKA check my AI knowledge. This is actually VS Code. Yeah, it's just a turn. It's just like this is just a plugin you can download that says GNU Emacs at Arch, so people think you know what you're doing. Integrate with a cursor. I just hit tab and the next lines appear, and I just make up some words, some buzzwords. Is this language gonna run on its own runtime, or is uses a Golang runtime underneath? This compiles to C, so the backend's all in C, and then so it's just its own. There's no like runtime unless you consider glibc a runtime or whatever libc link you have. All right, this has to return a variable declaration. Which is kind of ambiguous because I do kind of push it instead of returning it, which means it needs to return. So it's a transpiler? Yeah, kind of. Is there a browser extension for Twitch that integrates all of the chats in whatever platform you're chatting from? I know there's people have sent me tools on how to do it, but I've never. I just have both of them open side by side in my other window. I could probably do some plugin thing that shows it on screen, like that puts it like in a, has them pop up. Ooh, but other people's tools, yeah. That's why I didn't do it. That's why I didn't install it. I don't trust other people's code. They're just trying to steal my passwords. Okay, oof. What about Gook? Like Go on C? Since it is Go syntax and a C backend. Good work. Thank you, Jerboa Ice. Thanks for the follow. Appreciate it. Welcome. What are the features you're looking for? Oh, to make for this language. I don't really have any like big groundbreaking features, but like I want to see how far I can get with like discriminated unions types instead of interfaces, and like comp time things and arena allocators and stuff like that. How far without a type checker? Type checker is going to be one of the soonish things that I do. I desperately want a type checker. That's like the next thing I want to add. But there's I want to migrate a few more C blocks over. I have types, I just don't check them. Like I can make types, but like this expression right here, you don't check your types, bro. This expression right here like doesn't check any types. But C checks some of the types, so. I wonder if you consider a type declaration a statement. I guess it would be. This is maybe a statement then. What's the syntax gonna be like? This is the syntax. The syntax is like exactly what Go looks like, pretty much. Type as any, easy peasy. Are you coding methods? Yeah, I want methods. we're gonna return the variable declaration. Needs a type checker to select the seg fault when you have a type fault. Boom, 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 boom. I wonder if I'm gonna throw in like a global. That is one tricky thing with unions. Right now my unions are only a union. It would be nice to put like a global boolean that applies to all of these things though, without having to add it to each one of them. I don't know. I'll think about it. Yeah, I guess we'll push to a symbol list. The problem is, if I call this from a global scope, I guess I could just check the global scope again. Or maybe I check this externally. Yeah, that's what we do. That's way better. That's our for statement. We don't want to do that one. We want to do this one. If parser scope depth is 0, then we do that. Else we do, shoot. Is it called write vardecle? To output VD. All right, we'll do the printing here. Can you have a seg fault in Golang, but it manages it underneath? Yeah, Go does panics, which are kind of like exceptions. They unwind. They unwind the stack. There are C libraries that do it. I haven't investigated it too much yet though. It's not something that's like generally supported by C. It is a nice feature to have though, so. But you can do stack traces for sure. I just don't know if you can do exception style unwinding like super reliably. Okay. Okay, so we don't have a left brace. I guess we look for a var keyword. Move it to var declaration, if there is one. Else, If we don't have a variable, no, this isn't very expandable though, like looking for a var keyword, because I'm never gonna have that. It's just gotta be like parse, it's gotta be just parse statement or something like that. I mean, it is technically an expression. I think my AST isn't cleaned up enough to like really do this. I might undo. I might undo and just expand my AST now. Because it's just getting too unruly, I think. I'll stash it just so it's like... You can handle that as expression, that's better. Yeah, I agree. The problem is like, because I was doing the code generation in line, there's just a lot of things that are not in the right spots. I looked at the benchmarks recently. It looks like C# is not that far from Golang. In some cases beats it, even in IO, which was wild. Yeah, I mean, you have to be a little bit careful with language benchmarks just because you don't know exactly what's like being measured for them. But for like application benchmarks, you might get a better sense of how they do. That's cool. I mean, I guess I could see C# doing fine. I guess it gets compiled as well, right? Or it gets JITted or something, I don't know. Compiled, yeah. AOT. That is a JIT. I always wanted to use a more obscure language, but I tried Nim for a while, but the ecosystem is always lacking. Yeah, I mean, that's the thing with obscure languages is people only build what they need. If you don't have a lot of people building stuff, then there's not a lot of stuff that's built, right? Okay, let's go ahead and start building the push for OSS isn't as prevalent in established language. Oh yeah. The community for OSS. Is it a JIT since it uses a VM for the bytecode? But I think it can do AOT, Microsoft Java. Well, JIT is just when they compile the bytecode to machine code dynamically. There is AOT, which turns it into machine code to native. But it will compile the whole runtime too. So I'm going to Golang. They added it a year ago. Oh, okay. Yeah, they can compile it all ahead of time, I guess. But it might have some dynamic JIT capabilities as well. But you could have a bytecode language and then add JIT to it so that it can run a little bit faster. Like just compile things down to machine code dynamically. But then you have to include like a assembler, or not an assembler, you have to include like the back end of your compiler with every application so it can JIT itself. What a funny phrase. So it can JIT itself. Okay. Um. Bum, 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 bum. It might make sense to make some union helper functions. I'm trying to think of how to structure this. What do you think of return? What do you think for return type of fixed index arrays? Do I handle the index bound checks on the semantic phase or not? For return types of fixed index arrays. Do I handle the index bound checks on the semantic phase or not? I guess I don't know how yours is broken up, but I also don't really understand what you're asking. Are you talking about making sure the return type matches the value that's being returned? Like making sure the length matches? Stuff like one int and function return 2030. Oh, like the function returns a different size array. I feel like I would do that in the type checking phase. Like you always want to make sure that whatever gets returned is the type that is. Yeah. How far are you in the language building process? To do. We are here. Lexer parser, structs, we have unions, enums, switches, ors and ands, pointer get operators, helpful postfix operators, global variables. And then we have hoisting now. And we have composite literals. Oh, we did index operators as well. And then I was working on this one. For loops with a single statement. So you can do like for something, but it's not really working. We need this repo to be public so I can update the README. There's no README. This is just my to-do list. I don't even push this repo. This repo is just on my computer. It's not backed up anywhere. All right, I can try to make one if you're interested to look at the code. I'm not gonna like it's gonna be just me working on it. I'm tempted to make a union type that's like this. do you probably get? GitHub or GitLab? I use GitHub. And I use my computer, yes. But I might just make this a I might just move this to be a statement. Yeah, let's do that. Okay. I'm gonna rename this to a statement, and then do all struct types. Let's do etc. Okay. Yeah, we've not made any changes. We have kind of a clean slate. So we'll go ahead and just rename this, and then we'll loop through everything. I don't love that though, because I kind of did it for that, I guess. And it's like you're putting a statement inside of your symbol table. I guess I'll just, yeah, maybe you're right. If I just do statements, because I want one thing that's like everything. I think the statement will be like everything. Everything funnels out of a statement, I think. And when I'm doing symbol table stuff, I'll probably have them separated, honestly. No, maybe I won't. But I'll be able to look up what type of statement it is, I think. Or really in the symbol table, I'm just gonna map the type to the whatever you call it. Boom, 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 boom. All right, we'll give it a listen. Another cool one. I use Git locally usually. Usually I push stuff, but I'm just kind of just starting this project, so I don't really have a repo for it. Typical is better. Oh, you already wrote that, sorry. Yeah, I like this. This is a good one. Okay, we'll just throw everything into this. We can get rid of these. And then this will probably... Every symbol will be a type definition instead, I think. Oh, sorry, I didn't realize it was louder. I don't know why, but more big games do these post-rock heavy songs, like boss fights. Yeah, I mean, it might not fit their exact theme of what they're going for. I don't know. Oh, don't do, yeah. Nice one. I like it. You just make that? Two days ago, nice. Okay, let's just start at the very top. I'm kind of torn. I think I'm gonna go. Yeah, let's start at the top of the parser. And we'll try to just create an entire tree. I just don't want to build a tree walker. I guess we're in our language, we may as well, right? There's just gonna be a bunch of pointer hopping. I think what we'll do is we'll pull everything out to this declaration level for now. Let's start with statement. Maybe we won't start with statement. Let's start with function declaration. Function. Then we build the function type, and then we're just going to I mean, let's go ahead and let's fix this naming. Why do I keep typing that? Func type. Because these aren't types, they're technically going to be, like this is going to be a struct. What was the question for the func with different return array? Can you elaborate more? All right, there's that one. Struct decal. Let's do, let's make sure it builds. Got them all. Enum type. We'll do union type first. Union type. Man, I cannot. Why do I keep going to enum type? All right, there's that one. Then we'll do enum declaration. I'm just gonna do them all. And then var decal. Or sorry, it's enum type. Enum type. Func type will be func decal. Heard you talk about it before. How slow is Emacs? Why do you think so? It's not like that slow. It just doesn't do super well with large files. And sometimes some of the plugins will bloat the system, make it run a little bit slow, and then it just feels like it gets bogged down sometimes. I think a lot of that has to do with my LSP as well. Oops. All right, cool. All right, let's go to our function declaration now. I kind of like this 2 hops. I don't really have a good reason for it. So we're gonna delete all of this. Rename it func decal. We're gonna return a func decal. Thank you, Zero, thank you, man. Appreciate it. It's coming along. All right, so we build our function declaration, and then we will just return it. I really just need like helper functions for stuff like this. Do I still prefer to Vim or NeoVim? Yeah, I don't really know those very much, so I must. I've thought about doing like a learning day though. Consume. Oh, this is still intermediate. Shoot. Let's think here. Because we don't parse the body. The problem is the block parses a bunch of declarations, so it needs to have those all read out. So we actually can't even do this one yet. That should work though. Okay. We really need to stop at start at like the leaves and like slowly bubble this stuff up into an AST. That's too complicated. This one we could maybe reasonably do. Var. Okie doke. Expressions we already parse. Wait, what's the issue? So let me just see what the difference between these is. Parser scope depth. I mean, this should work here, right? Are you thinking of supporting fixed size arrays? Yeah, probably. Those days I coded a 16-bit VM custom assembly language in Rust. Oh, dang. Sounds fun. Sounds intense. I'm not sure why. I don't know why this wouldn't work. Oh, I actually do know why. Never mind. Because this is getting used in multiple places. This actually, does this belong up there? When I'm parsing, I know a little bit of info. I know that I'm not, I know if I'm in a function or not in a function. The problem is that on the outset, I don't know. This is the language syntax, what you see here. Looks like Go. Let's do this. I mean, it's just unfortunate because I already have this. Like, I want this. What do I think I want? I think I want this. And then I want to do if vd dot global or something. I don't know. If not global. Because I feel like I can aggressively throw while I'm parsing. I know if I'm parsing a global variable, and I can just push it to the list. I feel like I can do that for a lot of cases, but this needs to know that it's global when I'm generating. It needs to know it until I have an AST, and then when I have an AST, I can track the depth inside of that. It's just hard to incrementally get to an AST. I thought it was a lock-like lang. It started as one. Now it's a go-like lang. Hey, it could help though. It's a coglang. It could help. All right, let me just think here. In a block, if I read a bunch of declarations, and then one of them is a variable declaration, I need to be able to return the entire block. So I can't write anything here. Like the next big jump is to make an AST, a full AST, and then code gen on the other side. I don't think it'll be that hard. Let's just do it. Let's just go all the way. The problem is we have to go from no AST to a full AST. There's no like in between area. So we'll add the parser, we'll add this to the symbol table because we know we're at the correct scope depth for it, and then I'll return the VD. I mean, it's borderline like I do this. Like just comment that out. It just doesn't matter. Like we're not gonna be able to compile this. This is the that is the Steam there. Like we're just gonna have to keep returning stuff up. And then we'll have to rewrite the code generator. I really should have done this at the start, but lessons learned. right, let's do type declaration next. This is going to return a statement. Statement equals statement. This has to return a statement. Our statement. The C blocks, I'm not sure how to do actually. I didn't think about that. I think though, let's go see what they're all are, because I don't want these forever. All right, we've got a global, okay. We'll just store for this one. We're just gonna return we'll add that to the union. We'll statement dot C. Whatever. It's a weird word. Return statement. Okay. So we'll make this as like a C block. I guess we'll do this. C block decal. All right, that's that one. Semicolon, we don't have any statements there. I guess I could make a none statement. I guess we don't have to set that, do we? Alright, that'll be a none statement. Doesn't want to just have to return this. Now I'm wondering if it's better to have this be like a general declaration, like a global declaration. No. It's just not really clear in my head what the difference between a statement and a declaration would be in all cases. Okay. I think we have to return everywhere though. Except for here, we're missing one. Return statement. And then here, function declaration. Sorry, .as.ft equals this. Return statement. The problem is this doesn't return anything yet. And then each of these need to that'll work. I don't think it will because I think it gets casted as a keyword. We've got to make a node for each of these things. Return will be switched with 4. Wait. Yes. And then token left brace. We won't do that. We'll have to have block. Will have to be a block statement. Block. We'll do statement.as.block equals block. Then we've got expression statements, which do I have that already? No, I do not. Block. Expression. That'll house all of the expressions. Okay, let's add each of these now. right, we've got if statement, we've got switch statement, we've got return statement, we've got for statement, we've got block statement, we've got expression statement. I think an expression statement is just going to have... Actually, we don't need an expression statement because we're just going to call that the expr type, which is like the union for all expressions. Thank you, Tony Dev, for the follow. Appreciate it, man. Welcome. We'll need all the other ones too. What do I call it? If statement, switch statement, switch. We've got return statement, for statement, block statement. It's a lowercase. Or did I call it block? I'm gonna call it block statement. Maybe I should have spent more time fitting up unions before I went and did this. Okay. At least things kind of compile. All right, buddy. Thanks for stopping in. I'll see you later. All right, we have the if case, list of else cases. Else if. Switch statement, we've got our switch expression, list of cases, default, return statement, we just have expression, return expression. For statement, we have our init, we have our condition, we have our incrementer, and then we have our body. And then block statement, we just have a list of statements. I think we'll have to model it like this kind of thing. But I think I'm actually gonna take a break here because it's been a little while. 4.5 hours, I'm a little bit brain broken. Custom language, what kind of language? I'm just working on a little bit of like a C-like language that looks like Go. Just for fun. Yeah, it's coming along. I'm trying to this is the language. Like I tried to bootstrap it as early as possible, which ended up being kind of a nightmare. And yeah, makes it really hard to add features, but it's okay. It's less verbose than C already, so I guess that part's nice. But my union syntax is a little bit, it's very C-like union syntax currently. You have to set the tag and you have to set the value. But eventually I'd like for it to kind of infer that stuff, which would be nice. But anyways, yeah, I'm gonna hop off. I'm gonna end stream here, guys. Sorry. Take a little break. But thank you all for stopping by. I hope you all had a good time. And yeah, I will see you next time. Bye-bye.